Hi everybody, this is going to be a guide to soldering LongwaveTime HAT kit. All components that you need for this kit come in a small baggie. So alongside the PCB you have a 40-pin Raspberry Pi connector, connector for hats, and you have a few passes. You will need to spend some effort to get those passives out. And you will have a small piece of paper where you have essentially a picture of the board and where each component goes. You can refer to that, or you can check sales screen where the same information is also written. To do the soldering, you will of course need a lead-free or leaded solder wire, and any soldering iron will do, because even though this board does contain SMD components, they don't really have any strict requirements when it comes to solder temperature or anything like that. To get them out, you will need tweezers, because 0805 components can be tricky to get out otherwise. Do note that CAT entering your working area is purely optional, and it really doesn't help with soldering or functionality of the board. The easiest way to solder 0805 components to board is actually to put some solder on one pad and then just use tweezers to get component in place and reflow that solder, just sliding the component in. Once you remove a soldering iron, of course, that component is completely soldered on. For second side, you can just do it in place like you normally would. So this was first resistor, 330 ohms. You can now get two more resistors. Do notice that for each 0805 component there is one extra, so if this component flies away somewhere while opening, you should have additional component ready, so you don't need to search for it. I personally like to turn resistors right side up so you can see the values. That is purely optional. Unless you live in Australia, then you will need to keep them upside down so electrons can flow freely. When it comes to soldering, of course, the same principle as for smaller resistor applies. We just put solder on one pad, and once we have both pads with some solder, we can use tweezers to slide the connector into that solder while reflowing it. Of course, you can also do it in any other manner you prefer. I just found that this one works the best for me. Also, once you have one side tacked down, don't forget to solder the other side. Okay, and now we have both resistors soldered down. The last SMD component is a capacitor. Again, you will have one extra capacitor here, so if first one flies away, you don't need to worry. And opening special capacitors can be quite tricky, so extra component will probably be handy. When it comes to capacitors, you don't need to worry about the size. Even if you are in Australia, you can position it however you want. So for soldering, we are using the same method as we did for resistors. Tack the one side down and then solder other side. You can of course always reflow solder to make stuff look better, or just to remove the excess. So now the big boy comes. What I like to do with this head connector is I just first solder just a bit the one side of connector, and this is just so I can have alignment. So then I get it into the hand and just align it so it's straight and level on other side. Only once I do that I reflow, and of course you need to let it cool down, and then it will stay in place. At this time I like to do the opposite side of connector, and once that is also done, just shortly inspect it to know that okay, everything is straight, and then just go ahead with other side. Here this is much easier if you are using leaded solder, because leaded solder doesn't require as high temperature and does flow more easily as compared to lead-free solder. And do note that this is slightly sped up, so your soldering time will vary. If you by accident make mistake and put too much solder or anything like that, so it touches antenna like you can see here, don't worry, we can fix that later. The way I like to approach fixing any such error is first by trying to remove solder using soldering iron. Sometimes if you have a smaller amount it is going to stick. But if that doesn't work, just put solder wick on top of it and melt it, and of course solder wick is going to pull extra solder. Also note that from a technical perspective it's enough to solder these 3 marked pins onto the PCB because those are the only 3 pins that are carrying signal. However, I strongly advise you to solder each and every pin for mechanical stability. Once you have everything soldered on, inspect it so there are no bridges, and you can then proceed with placing it into Raspberry Pi. Once you are done with board inspection, you can attach it to Raspberry Pi. So board supports both Raspberry Pi Zero and full-size Raspberry Pi. Here I'm going to use a full-size Raspberry Pi, and it's like with every hat, you just align the pins and attach it. Do notice that this board does support the case, and that is actually the reason for this funky shape. And once you are done, you can fully enclose it into the case without any worry. Now for change of pace, we are going to install Raspberry Pi imager. You can do that from Raspberry Pi site. For image, I'm just going to select normal Raspberry Pi OS, and I will select my SD card and write it down. If you are using other operating system or you want to do it differently, there is guide on Raspberry Pi pages for example Linux or Mac or things like that. So once you are done, you can just click on continue and do 2 additional things. First thing that I really like to do is to enable SSH, and you can enable it by just creating SSH file without any extension on board. And second one is adding wireless data, and that is in wpa-supplicant.conf. And in this file, you need to enter this code and replace SSD and your key. If you do this, you don't need a keyboard or a mouse on your Raspberry Pi. You just boot it up and it will automatically set both SSH and network. Once done, eject. Give it a minute or two to boot up, and once boot up, just go to its IP address and enter Pi Raspberry as a password, and you are done with installation. To get TxTempus software on, we need to install a Git and build essentials. Once that is on, we clone the repository and we type make. Make is going to take a minute or so just to compile everything, and once done, you have TxTempus on. Now we can start TxTempus. Here I started with WWVB parameters that are appropriate for US. I can place my watch on top of Raspberry and put it into receive mode. Exact procedure differs depending on which emulation you want, and you can see that on TxTempus site. After a few minutes, you should see hands move, assuming there is a time difference, and your watch should accept the time. And that's all, folks.